Oh my God, are we there yet? We'll be there in like 10 minutes. You said that 10 minutes ago. Well, if you're so tired, then why don't you just walk back? Alone? I'd be killed in the first 5 minutes. Sounds like a win-win to me. Kidding. You guys worry me. Faith, you need therapy. Everybody take a chill pill. This is supposed to be fun. Besides, we're here. Hey, Genie, I think this fire needs a bit more fuel. What do you think? Huh? Right? Yeah, sure. Okay. Sorry, I was a bit distracted. Can I help? Oh, I mean, yeah, sure. Just light the fire. I have to go check on Faith and Ryan. They've been gone quite a while. Okay. That way. Yes.
Hey kids, do you want to learn about radioactive decay? Yeah! I thought so. To start off this lesson, there's something that you need to know. An isotope decides to decay because it has too much gosh darn energy and needs to lose some. Before it decays, it's called a parent isotope. After it decays, it's called a daughter isotope. An isotope is just an atom, but it has a different number of neutrons and therefore a different atomic mass. It is actually super easy to graph parent and daughter isotopes, as you can see. See now, on the x-axis, we have the number of half-lives, or the age. On the y-axis, we have the isotope amount in percentages. So this would be 50%. Now, as you can see, as time goes on, parent isotopes decreases, while daughter isotopes increase. We know that they do this at the same rate, because if you were to put a line right here, they'd be symmetrical. Isn't that cool? Well, that's the end of our lesson for today. Adios, classe!
What you doing? Cutting, wood. Yeah, for the, fire. Dope. Can I help? Sure. Thanks. You know, if that coyote that was howling over there decides to, pay us a visit, we'll be ready.
So it wasn't just a fantasy?
Yeah, I don't think that was a coyote. In fact, it kind of sounded like... Well, whatever it was, didn't sound good. Oh. I should check on Genie. Yeah, the howling sounded like it came from by the campsite. Yeah. Okay, see ya. We'll be heading this way. I think I saw some good wood. You know, it was really nice of Faith to set this up. Like, this is my first camping trip and I've been having so much fun. Hey, I'm done with this knife. Can you hold on to it for me? Yeah, sure, just hand it over. Catch!
Welcome back, chicos! Now that you've learned the basics of radioactive decay, let's get into a new topic, half-life. Yay! A half-life is the time it takes for half of a radioactive isotope to decay into a different radioactive isotope. Let's do an example. So sodium has a half-life of 15 hours. So, if we start with 100 grams, after 15 hours, how much will be left? That's right! 50 grams. Now we can do this as many times as we need to. If we do it again, after 30 hours, how much will be left? That's right, 25 grams. We do this as many times as it takes to get to 0 when all of the, if you remember, parent isotopes turn into daughters. We can also see, if we look right here, how as time goes on, the amount of isotopes decreases into a different one. That's all the time we have, kiddos. See you on the flippity-flop.
Oh my God, what did I do? Flare, backpack, good idea. Oh my gosh, Ryan, I'm so sorry. Here it is.
I'll call for help. You're gonna be okay. I promise. Okay. Help! Help! Ayúdame! Help! I don't know any other Spanish words!
What are you doing?
Calling for help! Wait, where's Genie?
Back at the campsite. Or more specifically, her corpse is back at the campsite.
Oh my god! Oh my gosh, wait, hold on, do you hear any cracking noises?
Now that you've learned all about radioactive decay, it's time to get a little bit more specific. There are 3 types of radioactive decay: alpha decay, beta decay, and gamma decay. For this lesson, we won't get into gamma decay. Alpha decay is where an atom lets off a helium particle to lose energy. When the atom loses the helium, it also loses 4 from its atomic mass, as well as 2 protons. The way we would write this is to start out with an element. We'll use polonium. Polonium has an atomic mass of 210 and 84 electrons. Once it goes through alpha decay, which we will write as 4/2 helium, we will see that we will subtract 4 from the atomic mass to make 206, and 2 from 84 to make 82. This means lead, so we can see how polonium went to lead. Now let's move on to beta decay. In beta decay, the atom loses a high energy electron and gains a proton. To do an example, let's start out with our old pal here, lead. Now, when lead goes through beta decay, which is 0, -1 electron, this is electron, means add a proton, we will see that we will subtract nothing from its mass, keeping it the same, 206, but we'll gain a proton, making it 83. This is the protons and the atomic mass for bismuth. This concludes our lesson. Adios for now! Yay!
I think I killed 2 people. I think I burned Genie alive. I stabbed Ryan. Do you think I could ever forget?
Well, that was easy.
Hey guys. Not for long.